I'm reading that because it's not working. All right, gentlemen, I'll be right with you. Cool. I think that's good. All right. What in here? Okay. All right, gentlemen. All right, I think we're good. Testing. Yeah. All right, sorry about that. Yeah, so welcome. So let me see. We're at the end of week, I guess this is week 4. All right, so today we're going to be doing a homework session for section 1.3 functions. As usual, if you have questions, feel free to either.
Are they all in here? What the hell?
Do you have a question? You okay? If you have questions, feel free to either type it in the chat or put it in the Q&A, or you can unmute yourself today because I don't think I'm going to use my microphone. And so we're going to take as much time as we can to go through as many homework questions as we can. So it's only 21 questions, but we didn't finish with my earlier group. So we'll start with question 2. This is the 2 p.m. Let me see. You can also anticipate exam 1 to become available this Sunday. Next week, I usually kind of devote the entire week to exams. So next week on Monday, we'll just take that whole class time to review for the exam as much as we can. And then next week on Wednesday, more than likely, I'll just use it as live office hours. You can take your exam during class if you want. You can take it beforehand. You can ask questions about the exam as you take it. We can kind of like work on it together. It'll be okay. Mr. Jean-Baptiste, do you have any questions? You okay?
Yeah, I'm good. Sorry.
Okay, that's no worries. Let me see. Yeah, so that'll be next week. Okay, we're here on question 2. So this question comes from section 1.3, question 5. It says, what's the domain of these set of numbers? I feel like this is fairly straightforward. Our domain is a set of input values. So I'm just going to list them out. It looks like it's -3 through 2. So -3, -2, -1, 0, 1, 2. Okay, I'm going to hit enter. The range is a set of output values, so we want the distinct output values. Let's see, we got -3, -5, 2, and -1. Okay. Is a given relation to function? So I think when we were going through this together, We said that if we have repeating x's, then it's not a function. I don't think we have any repeating x's here, so is this a function? We're going to say yes. Okay. So where'd it go? Random. All right, we'll go ahead and do question 3. Determine whether the following equation defines y as a function of x. Okay, so this one, let's see if I go here. Like this, I'm gonna close that. Here, I want to launch this one. Okay. So I just made a poll available. We're gonna let A be for yes and B be for no. What do you think? Let's take no more than a minute, right? So just take a moment. If you could guess, you got a 50-50, essentially a 50-50 chance of getting this correct. Just take a moment. We'll take like 30 more seconds. What do you think? So I would use like a Jeopardy theme song, but I don't want them to. I don't want to get hit with a copyright. So I got some non-copyright game show music. Okay. All right. So let me submit my result. I feel like this one is and I'm gonna submit. Is there a brave soul that would like to explain how they got their answer, or why did they choose the answer? Going once, going twice. Forever hold your peas and rice. Okay. Right. So I chose this one is yes. For instance, if you were to solve for y, you would get y equals negative x plus 10. That's just going to be a line. All right. One realization we had with my earlier group, when we solve for y, if y is to an odd power, more than likely it's going to be, if the highest power on y is an odd power, it'll be a function. If the highest power on y is an even number, then more than likely it's not a function. Yeah. So, but yeah, one thing we could do is look at the graph, right? I think we've explored using like Desmos or a graphing calculator, right? So I think most people chose A, so which is a yes. So we're gonna go with it. Okay. Ooh, hang on. Ooh, hang on. Stop. Sorry about that, gentlemen. We got some guys that came to the house dropping the tree. They were supposed to come 2 to 3. They were supposed to come around 3 o'clock, but I guess they got here early. So I really wish I could have got some footage of it, but we're in class. Yeah, so while we're here, I heard the tree crash. It just, and I was like, just wanted to make sure the house didn't cave in or anything. So, anywho, okay. So I think we're good there. Let's go ahead and do another one. Generate. So I was just checking on them, but they're good. It fell exactly the way they did. I think they did exactly what I was anticipating. Where, you put a line in the top of the tree and you put tension on it, pulling it away from the house. And so you have one guy cutting, and you have like a group of guys pulling tension, so it'll pull it away from the house, and then maybe an anchor and things like that. Anyway, they dropped it. They dropped it in less under 10 minutes. I was like, damn, that's an easy 1K. Anyway, took them 10 minutes, man. I was just like, son of a bitch, man. Because I'm cussing because I know I could have did that, like, especially if I had some help. But anyway, I think it was we'll do question 9. That's fine. All right, but like I said, I just wanted to check on them to make sure they were okay, but they're fine. The job is already done. Okay, so in this example, we're asked to find the domain of the following function. Okay, I want to actually take some notes on this. I just want to kind of write a few things out. Let me see, template settings. I'm going to do this one a little bit different. Come on. There we go. Okay, apply. Okay, we'll work with this. Aquí. All right. Let me see. So this one was talking about domains. Okay. So for our purposes, I mean, there's so many different ways we can talk about the domain of a function, but there are two main cases I just want to kind of bring to your attention. So, just this little quick blurb on domains. And we'll let the first one be, if we're talking about rational functions. Okay. It's a rational function is going to take on the form. It's going to be like n of x over d of x, where you have one polynomial divided by another polynomial, where the denominator polynomial is not equal to 0. So in general, for a rational function, the domain, so I'll say the domain is going to be all reals, so all real numbers. Sometimes you'll see me abbreviate that symbol like this. So all real numbers except any x that makes the denominator 0. Okay? So when we're working with rational functions, again, in general, the domain is all real numbers except any x that makes the denominator 0. And again, all the stuff that you see me writing, you'll get a copy of it at the end of class. I think last time I wasn't able to load it in the box, but then after my last class, I figured out a workaround. It seems like it's working. So you'll, long story short, you'll receive a copy of this at the end of class. So we have rational functions. The other one I want to bring to your attention is even root functions, like square root function. Like I'll say even root functions, or like, for example, like the square root function. Okay, so we talked about rational. So then with even root functions, we can't take an even root of, I'll just say it for the sake of time. We can't take the even root of negative numbers. So let me see. We can't take an even root of negative numbers. Okay. So in other words, the radicand, which is the inside part, has to be greater than or equal to 0. The radicand, I think it's a D on the end of that. The radicand must be greater than or equal to 0. Right? So for example, say we were considering f of x equals the square root of x, right? Then the radicand, which is the inside part, I'll do it in blue. So this guy has to be greater than or equal to 0. The radicand. Again, there might be a spelling error there. As long as you get the gist of what I'm saying, that's all I'm really concerned with. So the radicand is the inside part, okay? So when it comes to domain, these are the main two that we just want to have a grasp of. If it looks like a fraction, just keep in mind that we can't divide by 0. If it's an even root, we can't take an even root of a negative number. Those are the main two ideas there. Okay. Oh, also, we have this handout on tutoring. I may have mentioned it. I know at least one of my classes I mentioned it last time, but I'm just including it. So just information on tutoring is going to be in these notes, kind of at the top, right? If you want to screenshot this now, you can. So just so you have it quickly on file. But again, I'm going to include it when I submit these notes at the end of class. Okay. Okay, so now let's get back to the one that we were working on. So find the domain. So then, long story short, I want to take a moment. I want to give you a chance to do this one. So I'm going to relaunch the poll. And we'll take a moment, at least 30 seconds, to give this a go. And, is it A, B, C, or D? All right. Let's go to the next one. How many? I don't know. It didn't matter. Just take a moment. Let's take another 15 seconds or so. Is it A, B, C, or D? What do you think? Oh, no takers? Oh, you guys are making me nervous. Let's take a few more seconds to think about it. Okay, we at least have a taker. Do you agree or do you disagree? And I like this one. This one sounds like Who Wants to Be a Millionaire? Oh, okay. We get some different results. Okay. This is okay. All right. Let's talk about it. All right. So I'm going to submit my result and I'm going to close the poll. We'll take a few more seconds for latecomers. Oh, you guys are making me so nervous. Okay, let me submit and I'm going to end the poll. All right. Okay, so if you put B, you're close, but it's no cigar. What's the difference? Can somebody, is there brave soul that can explain to me the difference between B and C? All right, sorry, B and D. What's the difference between B and D? So if we look at the original, right, we want to remove any X that makes the denominator 0, right? So I think it's pretty clear that when X is what, -6, it produces a 0 in the denominator. So we have to remove X equals -6. So we don't want any answer to be -6, right? So basically the domain is going to be all reals except -6. So part A is missing half of it, right? It has the right hand side, but it's missing the left hand side. Same argument for C. It has the left hand side, but it's missing the right hand side. The problem with B is the symbol. It's very subtle, right? It's using a square bracket where actually it should be a parentheses. Parentheses means we get infinitesimally close to that number, but we do not include that number, right? It's really subtle. And it's really easy to miss and make this mistake. Where the square bracket, we get really close. We get infinitesimally close to that number, and we do include that number, right? So because we do not want to include -6, that's why the result should be D. So I'm going to go with D. Okay, check the answer, right? So, it's okay. We live and we learn. And so the thing about this experience is not about not making mistakes. It's about learning from your mistakes within time, like soon enough. Like you don't want to wait until an exam or you're in a proctored exam or you're on a job interview to start making those mistakes. You can't, you can't run from it. You can't avoid it. We all make mistakes. The difference is how quickly can you learn from your mistakes, right? Do you learn before you need it or after you need it? You see what I'm saying? So anywho, all right. So let's try another one. All right. But I'm glad we had that experience. And there's a little bit more I want to say there. When it comes to rational functions. Come on. There we go. Right here. Let me say this part. So let's do this. Say we have some real number K divided by 0. I'll call this a KO. We want to knock that out. So this is going to be an example of something that's undefined. It's going to be undefined. Okay. Say we have 0 over some real number K. Well, this is okay. All right. So this guy's going to be equal to 0. Okay. And then kind of a neutral one, or another case is if we have 0 over 0, 0 divided by 0, right? This is going to be either a hole or a gap in our graph. The red one is usually, it shows up as a vertical asymptote. All right, vertical asymptote. It's undefined. Okay. Green, so if we have some number divided by 0, that's going to be a vertical asymptote. That's a KO. But 0 divided by some number k, that's okay. So that's going to be equal to 0. And then 0 divided by 0, that's going to be a hole or a gap in the graph. Okay, so I just wanted to bring that to your attention as well. My dog is doing surprisingly well for them to be doing this construction out there. All right, so let's do a different one. Let's go to question number 11. I'm glad we're having this time. Oh, she heard me talking about her. She's like, "Are you talking about me? Keep my name off your mouth." Okay. Ooh. So this one asks us to find the domain. I want to give you at least 30 seconds to give this one a go. If you feel confident with your results, feel free to type it in the chat. Let me check the chat real quick. I think my audio is working because I can see my captions and nobody else has stopped me. So yeah, I think you got the right idea. But yeah, just take some time. Timer going, but that's okay. Let me see. So we'll just take at least like 30 seconds and see if you can, if anybody like feels confident in submitting a result here. Just take some time. How long is this? Let's see. Take a moment. So I'll go to my second hand, gets on the 3, and I'll start working it. Oh, nice. Oh, that was a 30-second one. Okay, cool. I like these. The timing is pretty good. Okay, cool. Okay. I know that goofy, but it doesn't matter. Okay. So the domain, right? So I think we have to combine, in this example, we have to combine those two different domains that we mentioned a moment ago. Like the first restriction is, we can't divide by 0. Additionally, we can't take the square root of negative numbers, right? So normally, like if we focus on that square root, the radicand, which is the x plus 7, would need to be greater than or equal to 0. But because it's in the denominator, it cannot be equal to 0, so it has to be strictly greater than 0, right? So I guess the best thing is for me to write it out. Let me get a copy. Because I could just put the answer, but let me at least write something down. Copy and delete. I like my little music. It adds energy to it, so it's not so boring. Because I know this stuff is boring. And it's tedious, all right? It takes a specialist. Don't expect the average person. You have a question? Come on. You're not going to work for me. Paste. No? Okay. Let me just try again. All right. This. I want to delete. Let me see. I want this. And this comes from section 1.3, question 27 from that section. All right. Let's try this again. Copy and delete. And you still not going to let me paste? We're tripping today. Come on. That's not working. What do I need to do? I know what else I can do. If this don't work, then I'm just not worried about it. Okay. Okay. So we're asked to find the domain of this guy. Okay. So again, if we were focused on the square root by itself, then we would say something like, we can go here, I guess. X plus 7 would need to be greater than or equal to 0. But because it's in the denominator, it can't be equal to 0, so we need to remove that bar. And now we have to extend the restriction to say x plus 7 has to be strictly greater than 0. All right. So if we subtract 7 on both sides, x has to be strictly greater than negative 7. Okay. So then now that's a set builder notation. If we just do a quick glance at the graph, say this is our -7. If the alligator is eating the bigger thing and x is bigger than -7, are we talking about the numbers on the left or are we talking about the numbers to the right? If the alligator is eating a bigger thing, are we talking about the numbers to the left or are we talking about the numbers to the right? All right. Okay. So we should be talking about the numbers to the right. Okay. So we want the numbers that are bigger than -7. So these are going to be the numbers going in this direction. Right. So then that's, and we would do a parentheses on this guy. Because what that means is that we get infinitesimally close to -7, but we do not include -7. So then now that we have this graph, I feel like from this point, it's easiest to write the interval notation. So the interval notation, the far left is going to be -7. The far right is positive infinity. Infinity always gets a parentheses. Because we don't include the -7, we use a parentheses there as well. Okay. So then we got this result as far as an interval notation. Okay. So we got from -7 to infinity. And so you guys are making me a little nervous, right? But it's okay. One thing I've noticed with the students, you never really know how it's going to go because, like, the students always make me nervous, but by the end, they usually pull through. Not everybody. I mean, everybody doesn't make it. We try to get as many people as we can on the other side successfully, but sometimes it just, despite our best efforts, we have to walk different paths. So, which is okay. It's nothing wrong with it. It's just a different path. No matter what happens, a couple of things to keep in mind. If you're talking to somebody, even if it's me or anybody, an administrator, and they're not saying what you want to hear, you're just talking to the wrong person. You got to find somebody else to talk to. And the other thing is, you got to be aware that you always have a choice, right? You always have a choice. Whether you think you do or not, you don't. The fact of the matter is you always have a choice. So, no matter how things are going, if you don't like how things are going, you got to choose something else. You got to make a different choice. You know what I mean? But don't ever feel like you're trapped because that's not true. You always have a choice. Okay, let me see. Let's see if we've done number 1. Okay, we'll go ahead and do number 1. So this comes from section 1.3, question 1. Okay, is this, I didn't want to do that. How can it'd be nice if I can remove that. That's fine, I'll just go with it. Okay, is this relation a function and give the domain? I'm not saying that that's the answer. I am going to start the poll though, because I want to get you guys feedback. Relaunch. Okay, is it A, yes, or is it B, no? Let's just take a few seconds. I guess I'll just play the next one. Next one's like 13 seconds. Yeah, just take a few seconds. Is this a function? Yes or no? Oh, that's the winner song. I'm not feeling that one. Let's go on to the next one. How long is the next one? This one's kind of long. We'll take like a few more seconds. So obviously it's not C. C is not an answer, an option. All right, we're gonna let this be. Okay, so let me see. I think when we kind of talked about this earlier, we made a statement like if we have repeating x's, it's not a function. So I am going to submit this result, submit, and I'm going to close the poll. Okay. So most people said A. Let's go with A and see what happens. Okay. And again, if anything isn't clear, feel free to either unmute yourself or type in the chat with the Q&A, and we can answer questions there. The domain is going to be our set of input values, right? Our set of input. So 10, 21, and 1. 10, 21, and 1. That's fine. A set of output values is the range, 17 and 19. Okay, not too bad. All right, let's go to question 15. We're halfway already. Party's almost over. What a bummer. All right. Anybody know where I got that from? All right. Okay, I'm gonna relaunch the poll. This should be quick. It's just nice to get feedback to get a sense of the audience. I will let this one ride. Just take a few seconds, at least 15. What do you think? Is it A, yes? Is it B, no? Is it A, yes? Is it B, no? Okay, what do you think? Ooh, interesting. Okay, so anybody feel confident in coming online and explaining how they got the answer? Let me see. I'm not going to pick on anybody. Okay. So, right, it says to use the vertical line test, right? If we draw a vertical line through this image, how many will it touch the graph more than once? Well, if the image is a circle, right, it's going to touch the graph more than once. So I think we got a couple of people that got it right. It should be no, right? It's gonna. This is an example of something that will fail the vertical line test. Just look at it and the answer's there, right? Let me plug this in. Oh, good job. But then they also had a crew. I would have been doing that by myself. They did that so fast. They just, man, in under 10 minutes. That's crazy. And then they didn't have no cleanup because it's like down in the woods already. But it was close enough to the house where it needed to be cut down. It died already. So, anywho. Okay, let's do some more. Generate. Question 10. Okay. So again, that last one was an example of something that would fail the vertical line test. Find the domain of the function. Okay, I'll give you a little bit of time. I would like you to. I'm gonna get to the next song. How long is the next one? A minute. Okay. We'll let the next one ride. It goes for a minute. So just take a moment, and if you feel like you can get this one, I'll put the result in the chat. Can you find the domain of this guy? Let's take a moment. Nominator looks like it's after ripple. No, just anywho. How much time is that? Take like about 30 more seconds. What do you think? Ten seconds. All right. Okay, so let's walk through this one, right? So this is like one that we mentioned earlier. We said this is like a rational function, right? And we said that for rational functions, we cannot divide by 0, so we have to throw out any x that makes the denominator 0. Can anybody tell me what value of x makes the denominator 0 here? If we set the denominator equal to 0 and solve, what do you get? Right? So we have x squared minus 1 equals 0. We add 1 to both sides, take the square root. So plus or minus 1, right? So we have to throw out plus or minus 1. So we want all reals except plus or minus 1. Okay. So now how do we capture that? So let me see. The far left, we're going to go from negative infinity to negative 1. Cup. And then from negative 1 to 1. And then from 1 to infinity. Okay. All right. So I don't know how obvious that was or was not, right? I feel like that interval notation is not obvious. So, it's, the assignments are here, and then I will say that whoever does the most talking does the most learning. The only reason I know this stuff is because I talk about it like all the time, right? That's the only reason I know it. But if you're like shy, or if you're not engaging, or if you're quiet, if you're not like thinking or engaging, it's a lot harder to learn versus if you speak up and the more you talk about it, the more you're gonna know it, like just by default, right? But it's I'm not gonna stress about it. Oh, here it is. I was like, where did the thing go? Let's see. Have we done question 3? We have, so we'll go ahead and do question 4. Determine whether, okay, this is a good one for the poll. So I'm going to relaunch the poll. You got a 50-50 if you guess, right? Just take a moment. How long is the next one? The 30-second one would be good. We'll go for like 20 seconds. Does this define y as a function of x? Okay. Okay, take a few more. We got about 5 people engaged. All right. So, is there a brave soul that is willing to explain how they got their result? Like, why did they choose what they got? Anybody can choose, a multiple choice, but it's not about. This isn't really about choosing the right answer. This is about why are you choosing what you're choosing, right? It's less about getting the right answer. It's more about why is that the right answer, right? So this one, I would say, does this equation define y as a function of x? If we were to solve for y, right? I think earlier we mentioned something saying that if the highest power on y is even, and we go to, like, for instance, in this case, if we took the square root on both sides, when we take an even root, we have to include plus or minus. That plus or minus causes it to not be a function, right? It's going to fail the vertical line test at that point. So does this equation define y as a function of x? We would say no. No, right? Okay, so that was interesting. We're doing pretty good. We got less than 10 minutes remaining. How many more questions do we have? Oh, we got a good amount of questions. Generate. Let's start around 13. Okay, we'll do 13. Vertical line test to determine whether the graph is a function. Okay. So it's kind of hard to see. Can we pop this out? Can we move it over? Okay, I think that works. Almost. Can't move that. Okay, so I'll hold it there. So let me relaunch the poll because I do want to give you a chance at this one again. It's a 50-50. I see the person chooses C. I can see your name, right? Even though I'm not showing it, I can see it, so I know who you are. So it's like, just so you know. And it does come into play. You don't want it to stand out like that. Let me. I'm gonna let this one ride. Just take a few moments, right? So use the vertical line test. Does this graph? Is this a function? Yes or no? In other words, does it pass the vertical line test? Yes or no? In other words, no or yes. All right, we're gonna take a little bit more time. Okay. So let me see. When I look at it, does it pass the vertical line test? Do I see any? Okay. I am going to submit this result. Submit in the poll. Okay. All right. So basically, we're asking ourselves, are any of these points stacked on top of each other? Right? Are any of them stacked on top of each other? No. Right? So in other words, this is going to pass the vertical line test. Oh, shoot. Did I choose everything? I think I did. I don't know. I think so, yeah. So it passes the vertical line test. So is it a function? We would say yes. Okay. Okay, what's the time? We got like 5 minutes remaining. Generate. Oh, I think this one's a doozy. It's not really a doozy. Okay, so it says students here. Well, we don't need this right now. So students have envelopes for extra money. Their initial cost to obtain the information for the job was $240. Each envelope costs 3 cents, and they get paid 5 cents per envelope stuffed. Let X represent the number of envelopes stuffed. Okay, so we have a cost function, a revenue function, and then we want to find like the break-even point. So let me see. Their initial cost was $240, and each envelope costs 3 cents per envelope. So then our cost function, if it's 3 cents per envelope times X plus a net fee of $240. So every time they make an envelope, for depending on how many envelopes they make, it's a net charge of $240 plus 3 cents for each envelope, right? But then they're earning 5 cents per envelope. Okay, so 5 cents for each envelope. Okay. So then determine analytically the value of X where the revenue equals the cost. Okay. So I'm gonna take some notes here. We can say basically going to say the first equation equal to the second equation. 3 cents plus 240. Okay. So then if we were to solve for X from here, we could subtract 3 cents from both sides. We would have what, 2 cents equals 240. Okay. And I'm just taking my notes here. Being a little bit lazy. That's like what, 2 over 100, which is like 1 over 50 or 2 over 100. So add on 2 zeros, 24,000. So then 12,000. So X equals 12,000. Right. So if they process 12,000 envelopes, that's when they're going to break even. If they process anything less than 12,000, they're going to be in the red. They're going to be paying out of pocket to do whatever they've done. They would not have turned a profit. They don't turn a profit until the 12,000 and first envelope that they process. Anything over 12,000 is profit at that point. Okay, that's interesting. Like this. Yeah. Anyway. Well, so I think about this a lot of times. Like I'll do like drives. Like I'll do like either DoorDash or Uber Eats, just randomly. And I tried it full time for a year, and what I found was like you definitely have the potential to earn like 6 figures doing it, but when you factor in like maintenance on your car, if you get any kind of fines or like run in with the police, things like that, it's not worth it. And then gassing up, and then just your time because it's like exhausting. After you kind of factor those things in, you're not really. It's difficult to turn a profit. It's not impossible. Some people make really really good money, and I don't know if it's like determined on like where you are, your timing. If you have to like clean, because like if you pick up people that are drunk, man, it's the worst. Like they're like children. It's like, man, what are you guys doing? How are you out like this? But yeah, but I don't know if like the juice is worth the squeeze. If how they like to say, I don't know if the juice is worth the squeeze with that. But I do feel like the rideshare stuff is I think it's a great supplemental job. Like if you have something else going and you just want some pocket change or play money for like just random stuff for like food or gas or whatever, I think it's perfect for that. But beyond that, if it's not, it should just be like play money that you do not depend on. Because the moment you depend on it, they're going to change stuff up, and they're trying to get you to work for the least amount of pay, and it's just not worth it. Okay, I think we got time for one more, and then we'll call it a day. Look at question 11. We've done that one, so we'll do 12. Find the domain. This is a good one. I'll give you like some time, so we'll do our poll. I'm going to relaunch this. So just take a moment to see if you can get this. That's fine. So what's the next one? The next one's a minute. We'll take a minute. That's about this. That's about as much time as we have. All right, that was a minute. All right, that's fine. That's close enough. Let's see. I think I'm going to guess on this one. Well, I guess there's no need to guess. Let me take a moment. So two numbers that multiply to give me that. Let me see. Yeah. Okay. Ooh. Let me make sure. Okay. Okay. All right. So I'm going to go with this result. And I'm going to close the poll. All right. So I guess whoever keeps choosing the wrong one wasn't listening, so they're gonna have to deal with that when it comes down to it. Again, you don't want that kind of attention, because when it comes to that little moment at the end where I got to decide, okay, oh yeah, I remember him. He was the one that was being dumb in class. I was like, okay, well, you're dumb, so I can't help you. Like that's what's gonna happen. I can tell you right now, that's exactly what's gonna happen. But anywho, right? So if we set the denominator to 0 and solve, basically this is factoring. If we got that minus 15, we're looking for two numbers and multiply to give us a negative 15 and add to give us a negative 2. So it should be a negative 5 and a positive 3, right? So then when we factor it, it's going to factor into a positive 5 and a negative 3, which it should be C, right? So I think I chose C, and I want to submit that result. Okay. All right. So maybe I'll pull these files later, and maybe I can do something with them. Okay. Are there any burning questions before we go our separate ways? Going once, going twice. Exam 1 becomes available this upcoming Sunday. You're going to earn up to 100% for the first 7 days. After the due date, the highest you can earn is a 95%. I want to say with all of our assignments, we get unlimited attempts, and again, a minimal or nominal late penalty. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend. We're going to meet back on Monday, same time, same place. Take care, gentlemen. Peace. Template. This one, apply. I'm going to suppress this. Sure. Here. Come on.
Goodbye, sir. Have a good day.
Take care. Notes.
Thank you.
Updated daily. Come on. I thought this is the right location. Oh, I kind of want to do that. I'm sure we got 10 minutes. I'm live streaming. Share my screen. So if we got 10 minutes, I'll try to do a quick draw. While we wait Siri, set a timer for 8 minutes.
8 minutes starting now.
I don't have time for a full match. And more than likely it's going to be lagging. As I'm streaming. Whenever you're, I'll do it to you. There as well.
Welcome to Mobile Legends!
なるほど。
5 seconds till the enemy reaches the battlefield. Smash them! All troops deployed!
さて、どこから行こうか。 僕最強だ。
Turret is under attack! An enemy has been slain! Ally has been slain. You have been slain.
お目が高い。
Our turret is under attack! An enemy has been slain! You have slain an enemy!
僕はいつだって正当思いのナイスガイさ。
Ally has been slain!
Daijoubu. 僕から離れない。 僕最強だから。楽しくなってきた。なるほど。まだまだ。僕最強だ。勝つさ。ま、好きな地獄を選んでよ。僕最強だから。もっと欲張れ。僕最強だから。牙を抜くのが僕だけだと思ってる。痛い目見るよ。僕最強。無限はね、至るところにあるんだよ。僕最強だから。
Siri, stop.
turret is under attack. Our turret has been destroyed. An enemy has been slain. An enemy has been slain. Slain. Rampage.
楽しくなってきた。僕最強だから。いっそのことを。なるほど。
Like we can't get up there. Like nobody going forward. They're a lot more aggressive than us.
Our base is under attack. Shut down. Double kill. Triple kill. Shut down.
大丈夫僕最強だから 何が持ってきた知らないけど一人でも死ぬ僕らの負けだ
Like it.
大丈夫僕最強だから
Enemy double. An enemy has been slain.
I gotta go.
An enemy has been slain. Ally has been slain.
大丈夫僕最強だから無限はね至るところ
An enemy has been slain.
僕最強だから
Ally has been
All right. There we go. Come out. All right. So let me see how you guys are looking. Okay. Let me do this real quick. This one. Let's duplicate. All right, so this is item 20. This is the 3 p.m. All right. And then just want to clear out these. Yeah. I'll leave that one actually. Delete. All right. All right, so we'll start here. Okay, gentlemen. Let me see. So welcome. So today we're going to be working on the homework for section 1.3. You can anticipate exam 1 to become available this Sunday morning at 11 a.m. And for the first 7 days, you can earn up to 100% credit. After the due date, the highest you can earn is a 95%. It's a 5% late penalty. If you have questions, feel free to either unmute yourself or type in the chat or the Q&A. I am monitoring these. And yeah, let's just kind of get into it.
Wait, hold on. I have a question. I'm sorry.
How you good?
So you mean we have a chance to get up to 100? Meaning, like, are you saying we got multiple attempts?
Yeah. On all assignments, there are unlimited attempts.
Oh, dang. All right.
Okay. So do with that information as you see fit. All right. Only reason I allow it because I've been doing this for like I don't know how many semesters, and people do not blow this stuff out of the water. I felt like if it were me, I would just do it until I got whatever score I wanted. But you know, everybody doesn't want an A. So anybody that essentially wants an A can get it. You know, some people want B's, some people want C's, some people just like to waste their money and time. All right. So it's on you, however you want to work that. I just need each person to submit their own work, and we're gonna go like that. Okay. So let me get to you all's section. This one. Oh. 1.3 functions. Okay, I think I'm gonna switch these around because I kept looking for it to be on the right. And we're gonna generate, we'll start off with question number 6. All right, so this one asks us to determine whether the equation defines y as a function of x, right? So with something like this guy, I'm gonna start, there's a poll that's gonna be available. Poll, launch. So there's a poll that's available in Zoom. We're gonna let A be yes and B be no. We want to determine whether this defines y as a function of x, all right? So if we were to solve this guy for y, like if we solve for y in terms of x, we might subtract x squared on both sides. And then to get rid of that power of 2, we might take the square root on both sides. So if we take the square root on both sides, then we're going to have to include the symbol plus or minus. And because of that plus or minus, that's going to cause the image to fail the vertical line test, right? So if it fails the vertical line test, it's not going to be a function. I'm going to go ahead and end the poll, okay? So one realization that we have from our earlier group, when the highest power on y is an even number, then more than likely it's not going to define y as a function of x, because when we go to solve for y and when we take an even root, it's going to generate that symbol plus or minus, and then it's not going to be a function. But if the highest power on y was an odd number, and then when we're going to isolate the y, even if we do an odd root, we don't need the plus or minus, right? So does this define y as a function of x? We would say no. We could also look at the graph, right? We could put it in Desmos and then do the vertical line test, right? Or in our Texas Instrument. All right, let's look at question number 13. I use the vertical line test to determine whether this is a function. Okay, I'm going to relaunch the poll. A is no and B is yes. Okay, A is no and B is yes. Okay. So if we have this image, is this graph a function? In other words, does it pass the vertical line test, yes or no? Right? It would be no if you could find an x value, if you could find a location where you can draw a vertical line and it touches it more than once. This is an example of something that passes the vertical line test. I'm going to submit this result and close the poll. Okay, I feel like this one was a yes, right? It's a yes because no matter where we draw a vertical line, it only touches the graph once. We can't find anywhere where we can draw a vertical line and it'll cross it more than once. Oh, okay, you guys won that one. I got it wrong. Let me see where. Oh, I couldn't find it there. Now I see it. It's when x is 1, right? So you guys got it. So 2, you guys got it. I thought I couldn't see it anyway. So I got it wrong. I'm going to hit similar exercise just because I don't want to see the wrong. Let me see. Quick scan. Okay, same thing, all right? So we'll say no. Yeah. Okay, that's fine. You live and you learn. But we get the concept. It's just trying to see it properly. Generate. Let's go to question 4. 1, 2, 3, 4. Okay. Okay, so determine whether the equation defines y as a function of x. Okay, let's try the poll again. Relaunch. Go. Okay, so A would be yes and B is no. Just take a moment, right? I'll give you maybe like at least 30 seconds. So the timer is going. Just take a moment to see if you can get this one. Those are like sound bites. Can I put some loop? Is there a way for me to do that? It's kind of weird. I can't see my settings. Okay, that's okay. Okay. For this one, I would say that. So I'm going to submit this result and submit and close the poll. Okay, that's fine. All right, so for this one, right? So I think we had one similar just a moment ago, where if we were to solve for y, notice the highest power on y is an even number. So when we take the square root, we have to use plus or minus. That plus or minus causes it to fail the vertical line test. So then y is not a function of x. So it should be no. Check. Okay. Also with this group, so we have our homework quizzes and exams that are in Pearson, and then also each of you should be in some section of the lab with Dr. Lamar. So just make sure that you're doing that. I think we're okay. Let's generate. Okay, we can look at question 5. So that was 4. We'll do 5. All right. So determine whether the following equation defines y as a function of x. Okay, let me relaunch the poll. And let's just take a moment. Even if you were to guess, So this one, I would go with this. I'm gonna submit, and I'm gonna close the poll. Okay, so square root function, right? So square root, visually, like you could just look at the graph. Conceptually, what it is like the top half of a sideways parabola. That's the general shape of a square root. I think this one was that image just moved to the left by 5 units. So if we just have the top half of a sideways parabola, an image like that is going to pass the vertical line test. So it should be a function. It should be a, right? Okay. And let's generate. Let's do question 15. Okay, this one isn't too terribly bad. We'll launch the poll. Just take some time. Not a lot of time. There we go. Okay, I'll do that one next. Okay. All right, so this one shouldn't be too terribly bad, right? Does it pass or fail the vertical line test? So I'm going to submit this result, submit, and we're going to go with it. Okay, so now I have about 2 people engaging out of the 7. Is the graph the graph of a function? We would say no, right? Because this is an example of something that would fail the vertical line test. You can draw a vertical line. It'll touch the graph more than once, so then it's not a function. Okay. Generate. Was that 15? That was indeed 15. All right, let's do question 12. 15, 14, 13, 12. The domain. Okay. I am going to relaunch the poll. And just take a moment, give this one a go. Take at least 30 seconds. See if you can get this one correct. I'll do this one. That's fine. So just take a moment. Let's see if you can get this. All right. Okay. All right, so I'm thinking I'm going to go with this result here. Submit. Okay, and I'm gonna go ahead and close the poll. So I went with A. All right. So let me do this here. So a couple of things. So one, I think I don't know if this was the group. I know at least one of my groups I shared this information. So we have information on the tutoring. I'm going to include this in today's notes, so it'll be there the same way you access notes from before. And I kind of want to talk about this, right? So we're talking about domain now. For our purposes, we have like, I mean, there are multiple ways that we could talk about domain, but there are two special cases I kind of want to bring to your attention concerning domain. The first one is with rational functions. That's when we have one polynomial divided by another polynomial. And in general, the domain of a rational function is going to be all real numbers except any x that makes the denominator 0. Okay. So we have to throw out any x that makes the denominator 0, right? So the denominator cannot be 0. Okay. And then the other type of domain that we kind of encounter is when we're working with like an even root function. So like square root function, fourth root function, so on. So when it comes to an even root with the domain, we can't take an even root of a negative number. So the radicand must be greater than or equal to 0, right? So if we were to consider f of x equals the square root of x, the radicand, which is the blue x there, has to be greater than or equal to 0. Right? We can't take an even root of a negative number. So in this example, all right, I think we ended the poll, right? This is like a rational function, or this is a rational function. So we have to throw out any x that makes the denominator 0. So what we would do is set the denominator equal to 0 and solve, and we would have to factor. All right. So if we were to factor this guy, we would have what? X plus 4 times x minus 1, which the zeros in that case end up being, I think it's -4 and a +1. And we want to remove those, so that's why we went with A. So I'm going to go with the A there. Okay. Generate. See question 18. I use the graph to find indicated values of the function. Okay, so when x is 4, all right, when x is 4, it looks like the corresponding y, just take a moment. When x is 4, what's the corresponding y? Hopefully we're on the same page. And you're thinking, this guy, come on. Okay. Generate. Let's look at question 6. 2, 4, 5. I think we did 6 already. So we'll do 7. Determine whether the following equation represents y as a function of x. Okay, this is a good one. Relaunch. So is it A, yes, or B, no? Yeah, we'll do 25 seconds. All right, so we kind of talked about this just a moment ago. Oh, they're saying audio jungle. That's interesting. Thinking, let's see. Okay. All right. So let's see. Let's go with this result. Is there a brave soul that is willing to come on and explain how they got their answer? Anybody? And we kind of mentioned this earlier, right? Let me go ahead. I'm gonna go ahead and close the poll. So the highest power on y is an odd number, right? So when we go to solve for y, we're going to be taking the seventh root, which is an odd root. So we're not going to need the plus or minus. So that means our final image is going to pass the vertical line test. So then it should be a function, which should be a. Okay. All right. So it's less about what is the right answer. It's more about why is that the right answer when it comes to this stuff. You know what I mean? All right. Let's see. Have we done question 13? All right. We've done 13, so let's do 14. We'll take a few seconds here. Relaunch. We'll take like no more than 30 seconds. This is a quick one. Okay, I'm gonna lock in my answer. In other words, does this pass or fail the vertical line test? Okay. Submit. And lock. Okay. So this is an example of something that passes the vertical line test. So then we would say that y is a function of x. Okay, let's generate. All right, let's look at question 20. This one. Okay, I don't think I've done this one with anybody. It says the area of a square tile is a function of the length x of a side of a square. Write a function rule for the area of a square tile. Find and interpret a of 7. Well, area of a square would be what? The length times the width. So in this case, it would be x squared. So if we want a function, it should just be x squared. All right, length times width, x squared. So then if we let x be 7, 7 squared is what, 49? Okay. What does this mean? The area of a square with sides of length 7 is equal to this value. The length of the side of the square whose area, no, it should be the first one, right? Okay. Generate. Have we done 12? I think we've done 12 already. 13, 14, 15, 16. We'll do 16. Okay, so this one takes, I know this one's a little bit long. Okay, we can at least launch the quiz for the first part. Go. So is the point -1, 2 on this graph, right? Is the point -1, 2 on the graph? Let's take like no more than 20 more seconds. Interesting. All right, I'm going to submit my result. I got this. Okay, let's see how do we do. Maybe, you know what? I mean, I probably got it wrong. Let's see. So basically, let's let x be -1. So then -1 squared is going to become +1 times 3 is 3. Plus 1 will give us a 4. 4 minus 2 is indeed 2. So then is this point -1, 2 on the graph? We would say yes, right? Because when x is -1, it looks like it generates a 2. So, okay. If x is 2, then what's our y value? All right, so just take a moment. If x is 2, what's our y value? Yeah, it's like with the poll. Once you submit a result, it doesn't let you submit another until I close it out. Okay. So if x is 2, right? If we plug in 2, 2 squared is 4, times 3 is 12, minus 2 is 10, minus 2 is 8. So when x is 2, it looks like the corresponding y is 8. Okay. Using this information, list the point on the graph. So that point would be what, 2, 8? 2, 8. Okay. If our y value is -2, and then what's x? Right? Let me see if I get a different one. Answer point. Oh, no. It's just a bunch of different answer things. So just take a moment for part C. If our y value is -2, can you solve for x? Okay, so with this one, I probably should take some notes. I am totally being a little bit lazy. Let me see. If we set y equal to 2, let me take some notes. That's going to be the best thing here. We're working on C. Ooh. It just hit me all of a sudden. Like I got maybe 20 minutes before my weekend started, so my mind is already shut off. Like I just want to kind of go on a bubble way. Let me see. Come on. Share a screen. Start the broadcast. Okay. All right. So we're starting, we have this f of x equals 3x squared minus x minus 2. And we want to solve for x when f of x equals -2. What's x equal to? Okay. So we're going to set the function equal to -2. So we're going to have 3x squared minus x minus 2 equals -2. If we add 2 on both sides, looks like we get this 3x squared minus x equals 0. Okay, looks like we can factor out an x from all terms. That's going to leave us with 3x minus 1. So then from here, we get that x equals 0 or 1/3. X equals 0 or 1/3. We got 0 and 1/3. So let's see, 0, comma, 1/3. Okay. So they want us to write the corresponding ordered pairs. Okay. So when X is 0, Y is -2. And when X is 1/3, Y is -2. The domain. So this is a quadratic general polynomials. The domain of a polynomial is all reals, right? So this one should be all real numbers. We're going to say from negative infinity to positive infinity. X-intercept. So if we want to set Y to 0 and solve, I'm going to take some notes. So for this one, we want to set Y equal to 0. So we have this 3x squared minus x minus 2 equal to 0. Okay. All right. So I want to use my AC method of factoring. So if I'm going to factor this guy, I'm looking for two numbers that multiply to give me -6 and add to give me -1. All right. Now this -6 is what? 1. The factors of -6 are 1, 2, 3, and 6. Right? These are the factors of -6. So then I'm going to do all the combinations of the factors and stop at the line that adds up to -1. Okay. So if I can do -1 and 6, that adds up to 5. I could do -2 and 3, and that adds up to +1, but we want -1. So we're going to do 2 and -3. These two numbers multiply to give us -6 and add to give us -1. So then from here, I'd have students that would use this technique called like a box method, where factoring a trinomial, something like this. In the upper left-hand corner goes the leading term, which is this 3x squared. The bottom right is the constant term, which is this guy. And then the other diagonal, we want to use those two numbers that we just found, writing x using those two numbers as coefficients. So we might say something like a -3x and a +2x. Okay. So then if we focus on the 2 on the top, what's the greatest common factor? What can we factor out of the 2 on the top? We can factor out 3x. Okay. What can we factor out of the 2 on the bottom? 2. What can we factor out the 2 on the left? It looks like it's just an x. And what can we factor out of the 2 on the right? It looks like it's -1. Okay. So our claim is that the original, has the following factorization. Our claim is that it factors into 3x plus 2 times x minus 1. Again, this is equal to 0. We can do a quick check by foiling. So we'll get 3x squared minus 3x plus 2x. It's going to be a -1x and then -2. Okay. So then from here, if we set each factor to 0 and solve, x equals -2/3 or a +1. Okay, so we got a -2/3 and +1. So we got a 2/3, comma 1. Fraction use commas to separate the answers as needed. Okay. And then the y-intercept. So oftentimes the y-intercept is like easier than the x-intercept. For the y-intercept, we let x be 0. So then if x is 0, then we quickly generate the number -2. Okay, that's the time. I don't want to keep you more. We got just shy of 10 minutes. We might finish a little bit sooner. Generate. Let's look at question 14. So that was 16. It looks like we've done 14. So let's just do the next question. Refer to the graph shown to the right. We're asked to find the domain. All right. So the domain is going to be our set of input values. In a graphical sense, that's going to be the very left to the very right. So you want to ask yourself, how far left does this graph go? What's the furthest left value? If we're trying to find the domain, what we can do is you kind of have to use your imagination. But if we took this image and smooshed it onto the x-axis, what values of x would it touch? Right. So the far left, that's called a projection. If we projected this onto the x-axis, so the far left looks like it's -6, and the far right looks like it's positive infinity. Okay, so type our answer in interval notation. So again, the far left we got was -6. The far right we got was positive infinity. When I say infinity, it always gets a parentheses. And because it looks like it includes the -6, we're going to use a square bracket. Okay. All right. Let's generate. Okay, let's have we done 20 already? All right, 21. Are these similar? It's okay. We'll go ahead and do it. Let me see. Are they similar? No. Okay, that's fine. So I'll kind of explain it a little bit. So it says students stuff envelopes for extra money. Their initial cost to obtain the information for the job was $110. The envelopes cost 8 cents, and they get paid. Ugh, man. I don't know if you can call this getting paid. Like, I don't feel like getting paid and 9 cents should be in the same sentence. It's just hard for me to process this because that's I mean, maybe I'm thinking too small, right? But they get paid 9 cents per envelope stuffed. Let x represent the number of envelopes stuffed. Express the cost function as a function of x. Express the revenue as a function of x, and then determine analytically the value for which the revenue equals the cost. So the net charge was $110 plus 8 cents for each envelope. Okay. So 8 cents for each envelope plus $110. But then they're generating 9 cents for each envelope. So we're going to say 9 cents for each envelope. Okay. So then the revenue equals the cost. If we set these equal to each other, these two equations, we're going to have like the 0.9 cent on one side and then the other equation on the other. We can subtract the 0.08x from both sides. When we do that, we're going to have 0.01x equals 110. So if we divide both sides by 0.01, that's the same as multiplying both sides by 100. So it looks like 1,100. Nope, add another 0. 11,000. All right. So what we're saying is they don't break even until they stuff 11,000 envelopes. If they do less than that, then they're going to be in the red and they're going to be spending money to do this job without turning a profit. They don't turn a profit until they produce more than this amount, right? So this is the break-even point. Right. So I think we got time for at least one more. I think we've done 14. I'll just do whichever one is next. So let's see. I think that's it. What the number is it? 17. Yeah, I think 16, 15, 14. So we'll do this one here. Okay, refer. Okay, let me see. So let me launch the poll. And this will be the last one. Put it right here. This one. All right, so F. Okay, let me see. So refer to the graph of f of x in the figure. The axes are marked off in 1 unit intervals. Okay, solve the equation f of x equals 4. Okay, so if we're looking at this image, right? When is our y value equal to 4? What are the corresponding x's where y equals 4? Okay. Yeah, I want to give you a little bit of time for this one. All right. So let me see. Timer 3. We'll try this one. Just take a moment. All right. So what are the corresponding y values? Sorry, corresponding x values where y equals 4? Okay. So I am leaning towards this result. Okay. Okay, so we're given that our y value is 4, right? It's those kind of 2 arrows going up to the right. So what are the corresponding x values that give us that result? Notice is from x goes from negative, or from the far left, basically from negative infinity up until -6, and then from 6 to infinity. Right? And the only one that captures negative infinity to -6 and 6 to infinity is E. So I'm going to go with E. Okay. All right, gentlemen. I think I'm spent. Are there any burning questions before we go our separate ways?
I had a question.
I'll make a copy in a moment. Yes.
Sorry. I had a question about our exams, and I was wondering, because I was looking on Pearson, I only saw quizzes. Where do we take our exams again?
Is he still here?
Hey, sorry about that. You still there?
Yes, I'm still here.
Yeah, I got knocked off. You had a question?
Yes, I was wondering where we take our exams. When I was looking on Pearson, I only saw the homework and the quizzes.
Oh yeah. It doesn't become available until this Sunday. So those have scheduled
Gotcha.
release.
It'll be on Blackboard or Pearson.
Pearson, it's going to be.
Okay.
When you're looking at the homework, you'll see like week 1, week 2, week 3, week 4, and then it goes week 6. So week 5 is going to pop up. And
Okay. Do you have office hours, or like you don't do that?
my office hours are Monday and Wednesday morning from 10 a.m. to noon.
All right.
But you can just call or text anytime. What were you trying to do?
No, I was just saying in general. I mean, I think I needed a little help with like identifying like if it's a function or not. But like I don't have anything specific. But if something comes up, I guess I'll just email you.
Yeah, a text. I have my office cell phone number. You can text me. If you're working through the homework, click on the button that says "Ask my instructor," and it'll send me a screenshot of your very question.
Okay.
That's the best way. Yeah. Let me check the chat real quick. Q&A looks good. I think the chat is okay. Okay, if there aren't any burning questions, again, exam 1 becomes available this Sunday on Pearson, where you find the homework and quizzes. And if there are any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And we'll meet back on Monday, same time, same place, to continue the next portion. Take care. Have a great weekend. Peace.